Okay, for this next section, we're going to review and expand upon our knowledge of exponent laws. So we know for exponents, in mathematics, an exponents are used as a short way to write a repeated multiplication. The number of small cubes in the diagram can be calculated by the repeated multiplication of a side length of 2 times a side length of 2 times a side length of 2, or 2 to the power of 3 in exponential form. Exponents can also be used with variables. If I said that I had a side length of a, and a, then that's just a to the power of 3. For a power is just any number that's written in exponent form. It consists of a base, the number that you're multiplying, and the exponent, the number of times that base gets multiplied by itself. If I'm stating the base and the exponent for each of these, then I'm going to say that the base is 4 and the exponent is 5. Here, the base is negative 3 and the exponent is 6. And for the last one, I have a base of x and an exponent of y. A number that multiplies into a variable is called a coefficient. In the expression 7p to the power of 3, the coefficient is just 7. So if I'm stating the coefficient of each of the following, well, the coefficient for the first one would be 8. The coefficient for the second one would be negative 3. And the coefficient for the third one divided by 7 is actually the same as multiplied by 1 over 7. Note that when written as a repeated multiplication form, 7p cubed is the same as 7 times p times p times p. If I had it all in brackets, then the base would not be p. The base is actually 7 and p. So it would be 7 times p times 7 times p times 7 times p, which would be 343p cubed. So there's a big difference between when they're in brackets and when they're not in brackets. When they're in brackets, that exponent also applies to the coefficient. So, if I wrote each of these as a repeated multiplication, kind of like our prime factorization form, then this would be the same as 3 times a 4 times a b. If I did example C, then this is the same as 3 times ab times AB times AB times AB, or when I reorganize it, 3 times A 4 times B 4 times. For example B, this is just 3 times A times 4 B's, and for example D, this would be 3AB times 3AB times 3AB times 3AB, which is actually the same as 4 3's, 4 A's, and 4 B's. If I'm evaluating a power, that's just me actually solving for whatever it is. So evaluating actually means if I don't have a variable, when I evaluate, I can solve for what that number would be. So in the first case, if I said evaluate 10 to the power of 3, or 10 times 10 times 10, that's the same as 1,000. If I said evaluate 3 to the power of 4, where I took 3 times 3 times 3 times 3, that's going to give me 81. If I evaluate negative 6 squared, where I have brackets, and the full value of the base is negative 6, then that's the same as negative 6 times negative 6, or positive 36. If I had negative and then 6 squared, because it's not in brackets, that's actually the same as negative 1 times, the base is actually only 6 squared. So negative 1 times 6 would give me negative 36. Once again, the brackets are really important to distinguish what the answer is going to be. So if I'm completing the pattern, then 10 to the power of 4 is 4 zeros. 10 to the power of 3 is 1 with 3 zeros. 10 to the power of 2 is 1 with 2 zeros. 10 to the power of 1 is 1 with 1 zero, which means that logically speaking, the next one would be 10 to the power of 0, which would just be a 1 with no zeros. If I'm doing the same thing, then if I have 3 to the power of 4, then that's 81. If I have 3 to the power of 3, then I could take that 81 and divide by 3 and get 27. To the power of 2, I could divide that by 3, or take away one of the 3's and get 9. Divide that by 3, and I get 3 to the power of 1 is 1, which means that 3 to the power of 0, if I divide by 3 again, is going to be 1. So the results are examples of a general rule with any base. When it's raised to the exponent of 0, the answer is always going to be 1. Anything to the power of 0 is just 1. So if I'm evaluating the following, 6 to the power of 0 is 1. Negative 9 to the power of 0 is 1. Negative 1 times 9 to the power of 0 is negative 1. And 2 times 6 squared to the power of 0, 6 squared to the power of 0 is still just 1. And 2 times 1 is going to give me 2.